All right, so for one of the projects I assigned to my students, I gave them a task of taking a data set and converting it into a database. And in order to do that, we need to create tables of data and normalize the tables. Now, I'm going to use for this example a little bit of a data set that I use to illustrate how to upload everything into class. Upload everything into the database in class. I pre-prepared it for the in-class example, but I want to go through a little bit about how I did the preparation so that you have a model for using Excel for that purpose. Now, Excel is certainly not necessarily the ideal way or the only way to do this process, but I thought that certainly you can do this in Python probably with a little bit of coding, but I wanted to sort of walk through exactly what I was doing so that you would have sort of a conceptual idea of how the tables need to be created in order to make this work. So let's start with some of these categorical variables because those are the main things that we are going to create alternate tables to connect back to our data for. So we want to, the idea here is that we want to reduce the amount of memory that we're using. And of course, every text entry is going to take up a lot more space in a database than a sort of numerical integer entry. And so all of these text entries, the states, the age categories, the opinions, things like that, we want to create basically smaller tables where we can use a foreign key to connect out to those tables. So I'm going to create a new sheet in which I'm going to put my opinions. So for instance, I know that I have in this database 5 opinions. I have, we'll call them the keys, and we'll call them the opinions. And there's 5 of them. And the first one, and we're going to put these in order because alphabetically they won't normally be in sort of sequential order. But we have strongly disagree. We have disagree. We have neutral. We have agree. And we have strongly agree. So we want a table like that. But we need, in the original data set, we need to replace the agrees and strongly agrees, these actual opinion values in text format, with their key values in the original data set, so that when we upload them to the database, there is that connection. So I'm going to create another column called opinion key. And I don't want to go through and do this with one entry at a time. I could create some sort of embedded if statements to do this. That wouldn't be too difficult. But I think that the easiest way, at least for me, is to first sort the data as a kind of filter. And then it's very easy to copy and paste the data into the opinion key column where I want it. So I'm going to take the entire data set. Again, don't just sort the one column because that'll break the connections with the data. So I'm going to select custom sort, and I'm going to sort by opinion. And now I have, they're in alphabetical order, so that's not necessarily the order that I want them, 1, 2, 3 is associated with initially. But agree, if we look back at our other table, was 4. And so I'm going to put 4 here, and then I'm going to copy 4 until I run out of agrees. Disagree was 2. And so I'm going to copy that until I run out of disagrees. Neutral was 3. strongly agree was 5. And strongly disagree was 1. And now if I resort my data from smallest to largest by the first column, then I have all of my replacements in my opinion key column. And when I upload this to the database, I don't want the text opinion, I want the opinion key column. And so I can delete the opinion column. And now it's now just replaced with these integers that when I save this other sheet here as its own separate table, then this will now be my table of opinion categories, and my individual respondents table will just have the pointer out to that other table. Now, information that is particular to the person, I generally don't want to do a table for. So like I don't want to do a table for salary, and I don't need to do a table for children. For one thing, they're already integers, and so I'm not going to save any space by having a table for children. I will want to do the same thing for state and age, and probably I should do something for gender, although gender 1 and 2, we could consider that already pre-coded. We would want a table that at least indicated that's a gender key, for 1 for male and 2 for female. So I can easily create that table 3, key, gender, 1 male, 2 female. So that column is taken care of. And then in my age one, when I do this, then I will also be able to explain from the note that's left here exactly what those age categories stand for. So let's create our table, P and age category. And I can also do definition. So again, from youngest to oldest, I can do young, or sorry, I can do 1 young, 34 and under, according to my note. 2, I can do middle aged, 35 to 59. And then again, according to my note, elderly is 60 and up. And so that information will be in my table. And just as with my opinion category, I'm going to create an age key column, and I am going to sort by age. Elderly was 3, category 3. Middle age was category 2. And then young was age category 1. I can resort my data, and age, middle age, young, elderly. Okay, it all lines up. And so then I can delete that column of data because it's in my other sheet. And I have the keys that point to the definitions for my other table. And then I would do exactly the same thing for states And so if I sort this by state, I have Arizona. Now, I don't have all of the states in the data. I only have 10 of them. I believe. And so, well, I could certainly include all of the states in the United States. For this example, I'm only including the ones that I actually have in the database. Florida is 3. Illinois, then Michigan, and then Minnesota. New York, Ohio, Texas, and Virginia. So resort back to the original sorted by person. We have our state keys here. Here's Virginia is 10, Texas is 9, Michigan is 5, etc. And then I can delete the state key, the state column. So again, individual data, I don't need, that's personal to the respondent. I can't really make a table for, but for especially text data that is repeated a lot, I've created these separate tables. They will be extra tables in the database. And so now I can just save each one of these as a separate table. The respondents table, for instance, this would be the state table. This would be the age table. This would be the gender table. This would be the opinion table. And then I can create a database from that. And everything is connected by these foreign key columns that connect out to that other table. Now, as I said, this is one way to organize your data in order to get it into a form that you need it to. You would want to save each one of these as a separate file. I saved them as CSVs for my in-class example. And then you would upload each of those tables separately to your database. But as I noted before, you can do this, import the whole thing into Python, and then, for instance, create these essentially if-then statements matching up opinions or things like that with integer values, and doing this cleaning process in Python if that's more efficient for you. But this is the idea behind what we're doing, regardless of the actual mechanism you use to implement it. So hopefully that will be helpful in setting up project 2 for the course.